In this video, we will analyze asymptotic notation. As we discussed in previous video, there are three mainly asymptotic notation, that is big O, small big O, and big omega and theta. In this video, we analyze big O, and through this analysis, we will go till little o, or we can also say little o as small o. As we discuss big O is nothing but f of n should be lesser than equal to some constant c of g of n. Okay, for all n is greater than equal to n naught, and c is greater than 1, and naught is greater than equal to 1. Then we can write f of n equal to big omega of g of n. Okay, so take one example, n square equal to big omega of n square. Yes, we can write, because n square is equal to n square, here equal to sign, and from any using any constant we can make it greater than this left hand side. So making right hand side somehow by using any constant, if we are able to make right hand side greater than left hand side, then we can say that there is big omega relationship established, or there is a relationship between two function is big omega. Or we can write n square is big omega of n cube, because here f of n is lesser than equal to g of n, or g of n should be greater than or equal to f of n. Here right hand side should be greater than equal to left hand side, and clearly n square is lesser than n cube. We can also write big omega of n to the power 4, or big omega of n to the power 10. Okay, we can write. Then these all are the greater than of n square, and n square is equal to n square. This is the tightest upper bound, and these are the upper bound. Right, and this is tightest upper bond. If we remove tightest upper bond, then we will get only upper bond, and the upper bond is nothing but, if we take only these function in consideration, then this is nothing but little o. Now what is the meaning of little o? If we remove equal to sign from this definition, then this becomes little o. If we remove this equal to sign, or we remove tightest upper bond, from this definition, then we will get little o. So what is the little o? We can write, for these example, we can write, if there is a and in right side there is b, then we can write a equal to little o of b, then b should not be not tightest upper bond, tightest upper bond. So if we want to write a equal to little o of b, then b should not be tightest upper bond of a, as here n square equal to n square or n square equal to big O of n square. This n square is nothing but tightest upper bound of n square, and if we remove tightest upper bound of n square, then we will get all the function which are upper bound or greater than left hand side. So this is nothing but little o or small o representation, and its sign is small o and lesser than. Small o and lesser than, and this is the mathematical representation of small o representation, or we also called small o as little o. Okay, thereafter we will discuss omega representation, and from omega we will discuss little omega. Okay, now we will discuss omega notation. As in previous video we will discuss omega notation is nothing but making left hand side greater than right hand side by using some constant c, and we need to find n naught. That n naught is nothing but the point from where this condition hold true. Then we can write f of n is equal to big omega of g of n, and this is the mathematical representation. We can write n is to the power 4 equal to, what the meaning, that here left hand side should be greater than right hand side. Okay, then if we can write n, no problem, n to the power 4 equal to n to the power 4 equal to n to the square, or we can write omega of n cube. Okay, and also we can write omega of n to the power 4, because here equal to sign is also available. Now this is nothing but, this is the tightest upper bond. This is tightest upper bond, this is nothing but tightest lower bond. This is less than n to the power 4 is greater than n and also n square n cube, and this is equal n to the power 4 equal to n to the power 4. Here if we remove this equal sign from omega notation, if we remove this equal sign from omega notation, then this become little omega or small omega. So if we remove this from here, then this will, we can say that all these are little omega, and little omega sign is this. Okay, so we can write this is the little omega or small omega, that f of n is greater than some constant g of n, and for all n is greater than or equal to n naught, there is some constant c, and also n naught will greater than or equal to 1. So small omega is nothing but small omega and greater than, and these all are the under small omega. Okay, so by using one example we will understand what is little o and big O, little o and little omega. If we talk about little o or small o, first we will talk big O. Big O, big O. In big O, if we say that I will come at 6 o'clock, then we can come at 6 o'clock or after 6 o'clock. 6 or less than 6. Then this is big O. And if we say that I will strictly come less than 6, strictly less than 6, then this is nothing but little o or small o. Small o. And in omega, if we say that I will come at say 6 o'clock, then we can come at 6 o'clock or after 6 o'clock. 6 or after 6. In small omega, then in small omega I will definitely come after 6 o'clock. Definitely after 6. In another word, if you understand omega and big O, then you can understand also small o and small omega, because if we remove equal to sign from both, that is from omega, if we remove equal to sign, then that become small omega, and from big O, if we remove equal to sign, then big O become small o notation. So there are mainly 3, and if we discuss more, then there are 5 type of asymptotic notation. First is big omega. In big omega, as we discussed in previous video, in big omega we need to make right hand side. In big omega we make somehow right hand side greater than equal to f of left hand side by using some constant c. In omega we will make left hand side greater than equal to right hand side by using some constant c. In theta notation we discussed in previous video that if omega and big O both are following for same example, then that will give you theta notation. And small o is nothing but if we remove equal to sign from big omega, then we will get small o, and from omega if we remove equal to sign, then then that notation become small omega. Okay, if we have any confusion, then you can write in comment box. Thank you.